Okay, so welcome back, and now let's introduce the definition of the area under the curve. So now that we've got all the terminology and we've got the other definitions and we understand the subintervals and the approximations, now what we're going to do is we're going to add limits to this thing. So definition 3 says let f be a continuous non-negative function on an interval from a to b, and let the summation from I equals 1 to n of f of x sub I star delta x be a Riemann sum for the function f of x. Then the area under the curve y equals f of x on the closed interval ab is given by this limit. That the area is equal to the limit as n approaches infinity of the summation of the Riemann sum. So in other words, a is equal to the limit as n approaches infinity of the Riemann sum. Okay? And this will give us the area under the curve on a closed interval from a to b. So now, before we go on, there's a couple of things subtleties. Taking limits of sums is a little different than taking limits of functions. We're not going to discuss that, okay, because that's discussed in a later chapter, and that's actually discussed, I believe, is it in, let's see here, where is it? Yeah, so this is actually not discussed in detail until you get the sequences in series, which is in Calc2. So we're not going to discuss that, but for the time being, we can just use limits and just treat limits the same way that we did with functions, okay? Another thing we have to consider is when we pick our sample point in the interval, first, what if the limit on the left and the limit on the right don't approach the same value? Well, the good news is that never happens. Okay? For continuous functions, that won't happen. Now, the proof of that is beyond the scope of this class, but that will not happen. Okay? The other thing too is about the choice of our sample point in the subintervals could give us either an overestimate or an underestimate of the area. Now, as I said before, turns out that our choice of our sample point doesn't matter. Okay, but if somebody was interested in finding an overestimate or interested in finding an underestimate for different applications, different reasons, then you could choose your sample points to be the sample point within the subinterval that gives you the maximum value of the function, right? So you could choose your, within each subinterval, you could choose your sample point to be the maximum, or the point that gives you the maximum of f of x, right? At the maximum point of f of x, okay? And that would be what we would call an upper sum. Or you could, if you wanted an underestimate, you could find the sample point, you could just find the sample point as where it gives you the lowest value of f of x at that point in that subinterval. And so what that would give you is that would end up giving you a lower sum. Okay? And so again, just little subtleties to talk about, but again, this is the definition of the area under a curve, and it uses a limiting process, okay? And this limiting process is going to be something we're going to use over and over and over again in several applications in Calc1 and especially in Calc2. Okay, have a great day.